So hello everyone, welcome back to the channel. Today we are going to discuss the problem generate parenthesis. So this question has been asked in various companies like Amazon, Microsoft, Walmart, Adobe, Google. So let's discuss the question. This is the medium type of problem. So we are given the n pair of parentheses, write a function to generate all combinations of well-formed parentheses. Let's understand the problem. So initially we are given n is equals to 3, let's say. So we have three opening brackets and three closing brackets. Now we have to generate all combinations, well-formed combination. The word we can see well-formed parenthesis. Why well-formed parenthesis? Let's say we can take opening bracket, opening, opening, closing, closing. This is fine. Why? Because this opening is closing this opening is closing this, and this closing is opening, like this opening is closing this, right? This is fine. But let's say if we take first opening bracket, there is no opening bracket for this. So this is not valid. Similarly, if we take this one, and this one, this is also not valid because this closing is closing this opening bracket, but this closing is has no one opening bracket. So we need to understand that for every closing bracket, there should be opening bracket there before. Okay. So let's understand the intuition that how we are going to form the well-formed parenthesis. So let's take a example for n is equal to 3. If we take n is equals to 3, so we know that we have three opening brackets and three closing brackets. So that means we have six positions to fulfill. So now every position has two possibilities, opening and closing. But we need to keep two things in mind as we have discussed that this is not valid. Why? Because we have one opening bracket, one closing bracket. This is opening bracket, this is closing, and this is closing. And this is not fine. Why? Because for every closing bracket, there should be at least one opening bracket. That means that number of opening brackets at any point when we are fulfilling the like array or combinations. So we need to understand that number of opening brackets should be greater than or equal to closing bracket. Why? Because if opening brackets are greater or equal, then it obviously means that closing bracket will fulfill, that this will be fulfilled. And if one opening bracket is there, this will also fulfill. So we need to understand that number of opening brackets should be greater than is equal to closing bracket. Second condition is that number of opening brackets should be less than or equal to n. Now why? Obviously, we can't take all the opening brackets and add in six positions. We can take only three opening brackets. So that means at every point we can't do this like opening, 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 opening. Rather, we need to understand that number of opening brackets should be less than or equal to n. So we have understood two conditions like opening bracket should be greater than is equal to closing bracket, and secondly opening bracket should be less than is equal to n. So these two are conditions that we have to keep in mind. Now let's understand the approach that how we are going to approach this and what techniques tips we are going to apply. Let's understand the approach. Now we can see that we have six positions. Fine. So at every six position, we have two possibilities, opening, closing, opening, closing. Then that means like when we take opening, we have two opening, closing. Now when we take closing, opening, closing, then again opening, closing. So we have many number of ways that are going to be generated. So that means we can purely understand here that we are going to apply recursion because we have to traverse all ways. And whenever we have to traverse all ways, we will apply recursion. Simple. So now let's do a dry run of any small test case to better understand it how we are going to apply the recursion. Let's do a dry run. So let's take n is equal to 2. If we take n is equal to 2, so we have two opening brackets and two closing bracket. Okay, fine. So if initially I will take opening bracket 1, so we need to maintain two count. Opening is equal to 0 and closing is equal to 0 initially. Because we need to check that is first condition is that number of opening bracket should be greater than is equal to closing bracket. This we need to check. And second condition that opening bracket should not exceed the end. These two conditions we need to check. So let's apply this condition and apply recursion. So here, when we take one opening bracket will be 1 and closing bracket will be 0. Now, we have to, this is fine. Why? Because number of opening bracket are greater than closing bracket. And we can take one opening bracket because we can take at most two opening brackets. Fine, fine. Similarly, here we have one closing bracket. Is this true? No. Why? Because opening is 0 and closing is 1. And this means that we are taking first only closing bracket. And this closing bracket will no one to be, will have no one to open. Okay. So that means we can't take this because it's not fulfilling this condition. Opening bracket should be greater than is equal to closing bracket. Similarly, we have here also two combination that opening. So here opening will be 2 and closing will be uh, 0. And that's also fine because opening bracket can be less than is equal to n. Similarly, can we take closing bracket? Opening will be 1, obviously, and closing will be 1. That is also fine because this closing will close this open. Fine. Similarly, we have opening. No, we can't take this open bracket. Why? Because we have n is equal to 2 and we have already taken two opening brackets. So this is not fine. Now when we take again closing bracket, is this fine? Yes, because opening bracket will be 2 and closing bracket will be 1. This is fine. But if we try to take again opening bracket will be 3 and this is also not fine. Now, when we take the closing bracket, yes, opening bracket will be 2 and closing bracket will be 2. And that is also fine. So, what combination we have generate? Opening bracket, then closing, then closing. So, this is the base condition that number of opening brackets is equal to n and number of closing bracket is equal to n. That means we have made the four points fulfilled. So that means, or we can take closing bracket is equal to n. This will also fulfill the criteria. Base condition, we can create anything like this one or this one, but we can't take opening bracket is equal to n. Why? Because that means if we have taken two opening bracket, that doesn't mean that we have fulfilled the condition. So that's why either we can take closing is equal to n or we can take both is equal to n. Both will work as base condition. So similarly, we have other combination possible. By the recursion, we will try out all possible ways and we are able to generate like this, and like all these. So these combinations are possible. So I think we have got it. So what will be the time complexity? The time complexity will be that now we have n. So at every position, we have two combination. Ideally, if we don't consider the condition, we have two possibilities, either opening or closing. But for how many times? 2n times. Because for n is equals to 2, we have four position, two opening, two closing. Okay. So we will say that we have two possibilities. So as we've done the, like, this is two possibilities, 2 into 2 into 2 into 2. So we are going to say 2 raised to power 2n possibilities are there. So what is the constraint given to us? The constraint is 8. That means 2 raised to power 16. And this is acceptable. This is acceptable. This is the time complexity. So time complexity will be 2 raised to power 2n. And what is the space complexity? Because we are going to use 2n stack space. Because we enter the functions, we are going to push them. So these are the 2n stack space. And when we remove them from the top and again add back. So obviously we have 2n. Stack space will be 2. So this is a like approach and time complexity, space complexity. So let's code up the approach. So given, let's create the solve function which where we are going to maintain the opening bracket, closing bracket, and string current and vector string of ampersand answer. So we have the base condition. What will be the base condition? Base condition will be that if closing bracket is equal to n, we can write like this as well. That is also fine, but directly write closing is equal to n. Then what we're going to do, answer dot pushback current. That whatever string we have generated till now, just push that in answer and just return from here. Now we have two options, opening bracket or closing bracket. Now for opening bracket, what we're going to check, that if opening bracket plus one, that if we had opening bracket and if it is less than is equal to n, so we need to check if opening bracket plus one is less than is equal to n. If it is yes, then that means we are going to opening bracket plus 1, closing bracket will remain as it is, and will remain as it is, and in the current string, we have added the opening bracket and answer will go as it is. Similarly, we will check for closing bracket that if closing bracket plus 1 is less than is equals to opening bracket, because we need to cover all, like for every closing bracket, there should be opening bracket at the front. That is a condition. So we are going to say if closing bracket plus 1 is less than is equal to opening bracket. If it is yes, we are going to pass opening bracket as it is, closing plus 1 and current will be added with the opening bracket and answer. So this is a like solve function that we have written. Now how we are going to call it? We are going to create a vector string answer and we are going to call the solve function with opening bracket 0 and closing bracket 0 and n will remain as it is. Current will be initially empty and answer will be passed by reference so that whatever we got in the answer, we are going to return from here. After completing this function, we are going to return from here. So let's try to run the code and check whether it's working fine. Yes, it is passing sample test cases. Let's submit the code. Yes, it's completely working fine. So this was all about code. If you like the explanation, please like, share, and subscribe to my channel. Thank you and have a nice day.